We've seen the formula for determining the power in an electric circuit. By multiplying the voltage in volts by the current in amps, we arrive at an answer in watts. Let's apply this to a circuit example. In this circuit, we know we have a battery voltage of 18 volts and a lamp resistance of 3 ohms. Using Ohm's law to determine the current, we get this: I equals E divided by R. 18 volts divided by 3 ohms equals 6 amperes. Now that we know the current, we can take that value and multiply it by the voltage to determine power. Voltage in watts equals current I multiplied by voltage E, so in this case we have 6 amperes multiplied by 18 volts, which equals 108 watts. So the lamp in this circuit is dissipating or releasing 108 watts of power, most likely in the form of both light and heat. Let's try taking that same circuit and increasing the battery voltage to see what happens. Intuition should tell us that the current will increase as the voltage increases, and the lamp resistance will stay the same. Likewise, the power will increase as well. Now the battery voltage is 36 volts instead of 18 volts. The lamp is still providing 3 ohms of electrical resistance to the flow of electrons. The current is now 36 volts divided by 3 ohms, which equals 12 amperes. This stands to reason. If I equals E divided by R and we double E while R stays the same, the current will double. Indeed it has. We now have 12 amperes of current instead of 6. Now what about power? Well, power equals I times E. 12 amperes multiplied by 36 volts equals 432 watts. Notice that the power has increased just as we have suspected, but it increased quite a bit more than the current. Why is this? Because the power is a function of voltage multiplied by current, and both voltage and current doubled their previous values. The power will increase by a factor of 2 times 2, or 4. You can check this by dividing 432 watts by 108 watts and seeing that the ratio between them is indeed 4. Using algebra to manipulate the formulae, we can take our original power formula and modify it for applications where we don't know both voltage and current. If we know only voltage and resistance, we can replace the current I in the formula for power, I multiplied by E, with E divided by R, and we get a different formula for power. Power equals voltage squared divided by resistance. Or in other words, P equals V squared divided by R. You can find the power if you know the voltage and the resistance in a circuit. To square a number means to multiply it by itself. For example, 2 squared is 4, or 4 squared is 16. Again, using algebra, we can manipulate the original power formula and modify it for applications where we don't know both voltage and current. In this case, we only know current and resistance. We can replace current E in the formula for power, I times E, with I multiplied by R. Then we get another formula for power. Power equals current squared multiplied by resistance, or in other words, P equals I squared times R. You can find the power if you know the current and the resistance in a circuit. There are 3 power formulae to choose from. The first is power equals current times voltage. In symbols, this is P equals I times E or V, or stating it in terms of units, one might say watts equals amps times volts. The second formula is power P equals voltage E or V squared divided by resistance R. Or you might say watts equals volts squared divided by ohms. The third formula for power is power P equals current I squared times resistance R. Or you might say watts equals amps squared times ohms. On a historical note, it was James Prescott Joule, not George Simon Ohm, who first discovered the mathematical relationship between power dissipation and current through a resistance. This discovery, published in 1841, followed the form of the last equation, P equals I squared R, and is properly known as Joule's law. However, these power equations are so commonly associated with the Ohm's law equations relating voltage, current, and resistance, E equals I times R, I equals E divided by R, and R equals E divided by I, that they are frequently credited to Ohm. Speaking of George Ohm and his formulae, which we call Ohm's law, there are the 3 basic equations relating voltage, current, and resistance. E equals I times R, I equals E divided by R, and R equals E divided by I. This magic circle is handy for remembering these formulae. If you cover up E for voltage, you get the formula for voltage, I times R, current multiplied by resistance. If you cover up I for current, you get the formula for current, E, divided by R. If you cover up R for resistance, you get the formula for resistance, E divided by I, voltage divided by current. In a similar way, the basic formula for power, P equals I times E, is easy to remember if you just think of the word pi. Draw a circle like a pie, draw a horizontal line across it, and put P on the top half of the pie. Drop a line from the center of the circle to the bottom of the line. I and E are placed in the two bottom quarters of the pie. Covering the letter P gives the formula for power. Power equals I times E. Covering the I gives another useful formula that gives current I if you know power P and voltage E or V. Current I equals power P divided by voltage E or V. Covering the E gives another useful formula that gives voltage E or V if you know power P and current I. Voltage E equals power P divided by current I. Using algebra to combine the three formulas of Ohm's law and the power formulas in all possible ways gives a total of 12 useful formulas. There are 3 formulas for each of the 4 electrical quantities: current I, resistance R, voltage V or E, and power P. One of the formulae for current I and one for voltage V has a square root sign. The square root of a number x is a number r such that when r is multiplied by itself or squared, it gives x. For example, the square root of 4 is 2, or the square root of 16 is 4. Here are the same 12 formulae for voltage in volts, resistance in ohms, current in amps, and power in watts, on a chart of a different style. Notice that this chart uses E for volts instead of V. Both E and V are used for voltage. Don't allow that to confuse you. Thanks for watching.